For this experiment, as we were saying, what we wanted to do is you want to prove that specific heat of water is equal to 4,200 joules per kilograms per kelvins. And we will be able to do that by using this virtual lab experiment. So this virtual lab experiment is all about the concept of calorimetry. So a calorimetry concept actually uses a material which we call as a calorimeter, which is here on your right side. So a calorimeter actually is a very insulated container that we use in order for us to measure a material specific heat. Insulated container means to say this is very much conserving heat energy. In other words, it's hard for heat energy to escape this container because the container is very insulated. Now, how do we start? Well, the first thing is we have to choose our liquid. So we have to choose water because that's what we want to prove, right? So for us to do that, we have to choose a mass. Best mass value is 100 grams because it's easy to convert grams to kilograms. It's just equal to 1 kilogram. Now for temperature, since we are talking about heat energy, we will be heating up your beaker of water to its boiling point to 100 degrees Celsius. Now you can't take the specific heat because that's what we want to prove. So therefore we will assume that we don't know yet the specific heat of water. Now for us to be able to measure its specific heat of water, after heating it up, we click next. Now what we have to do is we have to move forward to your calorimeter while the water here is being heated up. So in our calorimeter, we have to choose a different liquid as a way of comparison. So we choose ethanol because that's the most common thing here. So we set the mass as the same mass because it's easier to calculate it later on. Now for the temperature, we are not heating up your ethanol. So we have to choose a temperature that is standard when we leave a calorimeter inside a room. So basically a room temperature. So we choose 30 degrees. Here, since we want to compare we want to calculate the specific heat of water, we can now take the specific heat of ethanol as a way of comparison. But as you can see here, the specific heat is joule per gram per degree Celsius. So you can't use this. You have to use Google and search for the specific heat capacity of ethanol in terms of joule per kilogram per kelvins. Because as I was saying, those are our standard units of measurement. Now, afterwards, now that we have set our calorimeter with ethanol and our beaker of water, we click next. Now, in order for us to prove it, we are actually going to use the concept of conservation of heat energy. In other words, uh, we will be transferring all of the water that is being heated up to the calorimeter by clicking start. So as we click start, the water here will be transferred to the calorimeter. And as you can see, the mixture of water and ethanol, at some point, they will have the same temperature, or in other words, they will be able to reach thermal equilibrium. So if the temperature here stops, it means to say they have reached that thermal equilibrium. So suppose the temperature stops. As you can see, it stops at 74.08 degrees Celsius. What's the next step? Well, the next step is for us to use the concept, as I said, of law of conservation of energy, which states that the energy that is lost will always be equal to the energy gained. Now here, the energy of the water is the one that is lost because we transferred it to the calorimeter. So in other words, for us to verify the specific heat of water, we equate Q of water is equal to the Q of ethanol because since they reach the same temperature, their energy must be conserved. So we equate again your Q of water or energy of water with the energy of the ethanol. And we already know before that Q is equal to MC change in T. So therefore, you have to record everything. You have to take note of the mass of the water, the initial temperature of water, mass of ethanol, initial temperature of ethanol, its specific heat, and the final temperature. So by using um this equation, Q loss is equal to Q gain, where in that case the heat loss came from the water because it has been transferred to the ethanol, which is Q gain. We will be able to calculate and verify the specific heat of water through deriving and through simplifying this main expression. Now, I will not put into details the how to do the derivation because that will be your goal. You have to use the conservation of heat energy to demonstrate how to calculate for the specific heat capacity. So I will leave it to you. I just gave you the main resources.